Hello, I'm Dr. Zia Tahir. This video tutorial is solution to problem 5 by 3 from Engineering Mechanics Dynamics by JL Meriam 9th edition. In this problem, a body is formed from a slender rod and rotating about a fixed axis through point O. The angular velocity and angular acceleration are given as omega 4 radian per second and alpha 4 radian per second square. The instantaneous velocity and acceleration of point A are required. Since the body is rotating about a fixed point O, the fixed axis rotation equation from chapter 5 are used. So from chapter 5, using key concept angular motion relation, equation 5 by 2 and then equation 5 by 3, so they are being used here. So v vector is equal to omega vector times cross r vector, and then for acceleration, it is a first order derivative of the vector velocity. So it is either v cross omega cross v plus alpha cross r, or it is omega cross r plus omega dot cross r. So equation 5 by 2 and 5 by 3, they are used to solve this problem. To solve this type of problem, first you need to set a coordinate system, but the coordinate system already given as x and y. So x is positive towards right and y is positive towards up. So, and then assuming O as origin, so position vector of A with respect to O is determined. So from the geometry of the figure, point A is reached by moving along two parts. So it is from O going downward and then from there going upward to A in y-axis, and then in horizontal axis it is from O to right at this point and then further towards A. So point 5, if we're going to consider a triangle here, in this triangle, point 5 is the hypotenuse and angle is 20. So then the component of hypotenuse can be calculated. And from this point to A point, because the diameter is 2 times the radius, which is zero point 0.4. So then this is treated as hypotenuse in this right triangle. So then using 0.4 as hypotenuse using angle 20, so both of the components can be calculated. So in a triangle OBC, hypotenuse is 0.5. So then OB is 0.5 cos 20 and BC is 0.5 sin 20. Similarly, in triangle CAD, hypotenuse is 0.4, which is the diameter. So then CD is 0.4 cos 20 and then AD is 0.4 sin 20. Now the x coordinate of point A from origin is BC plus CD. So it is BC is 0.5 sin 20 plus CD is 0.4 cos 20, and it is 0.54689 meters. Similarly, for y O to A, so that is equal to OB minus AD. So OB minus AD is the y coordinate. So y coordinate of A, now that is the origin and y is taken positive as upward. So then O to B is negative. And then this D to A is positive. So OB, it is minus 0.5 cos 20 and then plus D to A is upward. So it is positive plus zero point 0.4 sin 20. So YA comes as 0.33304 meters. So our unit vector R, that is 0.5469 I. minus point, 0.33304 j. This position vector will now be used to determine the velocity and acceleration of point A. The velocity of point A is found using the formula V is equal to omega times R. From the figure, the angular velocity is counterclockwise, and by using the right hand rule, counterclockwise rotation in xy plane is taken as positive in z axis or in k direction. Therefore, omega is equal to plus 4k radian per second. So, after substituting the value of omega and r into the equation, velocity of A can be found. So, velocity at point A is minus 4k times r. R is 0.4569 I minus 0.33304 j, and then multiplying it. So, k cross I is plus j and k cross j is minus I. So, VA comes as 1.332 I plus 2.19 j, and that's the answer. This is instantaneous velocity at point A. The positive x component shows that the point A has a velocity towards right, and the positive y component shows that point A has velocity upward. This is physically reasonable because body is rotating counterclockwise about O. Now, instantaneous acceleration of point A is calculated from the equation from chapter 5, and then substituting the values of omega v alpha r, or using omega r alpha and r. So alpha, from the figure, the angular acceleration is also counterclockwise. Then using the right hand rule, alpha is the direction of alpha is plus k. So alpha is plus 7k radian per second. This is important. In this problem, both omega and alpha are in positive k direction. So I'm using equation. Acceleration at point A is omega vector into VA vector, because VA vector is already calculated, plus alpha vector into R vector. So alpha vector is now plus 7k. So by substituting the values in equation for acceleration at point A, omega plus 4k times VA plus alpha plus 7k times R, and then after simplifying it and multiplying and using rules, I cross j is equal to k, j cross k is equal to I, and then rearranging them and writing in terms of I and j. So acceleration at point A comes as minus 6.41893 I plus 9.15681 j. So the acceleration is at point A is minus 6.42 I plus 9.16 j, as per answer at the back of the book. So that is a complete solution to the problem 5 by 3. Thank you very much for watching.